we're starting our first unit in the grade 11. We're going to talk about, the first unit is going to be quadratic, but specifically quadratic in vertex form. Okay? So before I start, let's go quickly a review over what's the difference between quadratic and linear. Okay? So do you guys remember what is a linear function? How would a linear function look like? Straight line. Yeah. So a linear function is a straight line, right? So it's going to look like, for example, this. It could be going down. It could be vertical, horizontal. It's just a straight. Okay. Now, what would be the exponent for a linear function? What? It's a degree 1. Okay. So if you remember, the equation can look like y equal mx plus b, or it can look like ax plus by plus c equals 0, right? So as long as the degree is 1, right, on the x and on the y, that's a straight line. Okay? Now, we are going to look at the quadratic. Okay? But first, we're going to compare the difference between linear and quadratic. Okay? Quadratic, what do you know about quadratic? Degree 2, yeah, so exponent 2. Do you know the shape of the function? How does it look like? It's a curve. It looks like a U shape, yeah. So it's either opening up as a U, right, or opening down, right? We call this shape a parabola shape. Parabola. It's a symmetrical shape. We're going to talk more about the parabola shape, but this is the shape of a quadratic function. Okay? So we're going to look at how can we identify the difference between a linear and a quadratic. How can we identify it using an equation? So when I look at the equation, can I say it's linear or quadratic? If I look at the table of value, how can I identify from the table of value if it's quadratic or linear? And I'm going to look at the graph, right? How can I identify if it's linear or quadratic? So probably the hardest part is going to be the table of values, because the other two, they're pretty straightforward. Degree 1, linear. Degree 2, quadratic. Okay? Is it a straight line? It's linear. Is it a parabola? It's quadratic. Okay? So we have the equation that the distance traveled by a boy on a bike is modeled by the equation y equals 3x. Now, looking at the equation y equals 3x, can you tell me if it's linear or quadratic? It's linear, right? Why do we know it's linear? Because the exponents is 1. Yeah. So if you look here, right, y is mostly always just y by itself, right? But we say it's a linear function because it's a degree 1, right? So I was able to look at the equation and I was able to identify it's linear by looking at the degree. Now, if I look at the table of value, so what they did here is they gave me x values, and they plugged in the x values in for x, okay? So they did 3 times 0, 3 times 1, 3 times 2, so they replaced the x value here, right? They replaced it in for x, okay? And they found the y value. So 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, okay? So these are my y values. Now, what we need to do in a table of value to identify if it's linear or quadratic, I need to find the first difference. Okay? So when they ask for first, you're looking for the first difference. What does the word difference mean? first difference of the y values. Okay? So what we do is we take y2, so the second y, and we subtract it from y1. So we always subtract the bottom minus the top. Okay? So y2 minus y1. So that's 3 minus 0, that gives me 3. Okay? Then I move to the lower one. y2 minus y1. So I do 6, take away 3. That gives me 3. Then 9, take away 6. That gives me 3. Then 12, take away 9. That gives me 3. What did you notice about the first difference? It's constant, right? So it's the same. So because the first difference is constant, so if you look here, the first difference is constant, right? Because the first difference is constant, I know it's linear function. Okay? So linear, because this is because B slash C, first difference is constant. Okay? So in an equation, if it's degree 1, I know it's linear. In a table of value, if I do the first difference, I know it's linear. Now, when you come to plot this to graph, you're going to graph the x and the y points. Okay? So the x points 0, 1, 2, 3, 4, and the y points are 0, 3, 6, 9, 12. Now this is not going to be too accurate because I don't have the grid here. I'm going up by 3 on the y value, and I'm going up by 1 on the x axis. Okay? As long as you stick with the same scale on the y, you're good to go up by 3s, for example, or up by 4s, or up by 2, or up by 1. But you have to stick with it. You can't just go up by 3, then start going up by 5, then going up by 10. Okay, make sure that you stay. I've seen this. Trust me. Okay, make sure that, doesn't matter. The x and the y scale, they don't have to be the same. Okay, but whatever you pick for the y scale, you're going to have to stick with it for that question. Okay, so if you're moving up by 3, you're going to have to keep moving up by 3. So my points are 1, 3. So, sorry, 0, 0. I forgot the 0, 0. So 0, 0, 1, 3, 2, 6, 3, 9, and 4, 12. And I can draw a straight line. And I can see from the graph that it's a linear function. Are we okay with this? Let's look at the second example. All right, so looking at the height of a falling marble is recorded and modeled by the equation y equal negative 5x plus 2. So looking at the equation, what can you tell me? What can you tell me? Quadratic, linear, what is it? Linear, right? Because it's a degree 1. So I know it's linear because of the degree 1. in the x value into the equation, so it's going to be negative 5 times 0 plus 2, negative 5 times 1 plus 2, negative 5 times 2 plus 2, negative 5 times 3 plus 2, and negative 5 times 4 plus 2. Okay? So they're replacing the x values, they're replacing the x variable. So let's do the math. Find the y value. Negative 5 times 1 plus 2 is? Negative 3, because negative 5 times 1 is negative 5 plus 2. Negative 5 times 2 plus 2. Remember, multiplication comes before addition, right? So negative 5 times 3 plus 2, negative 13. And negative 4 times 2 plus 2 is negative 18. Okay, so I found my y values. Now I need to look for I need to look for the first difference. Okay, so the first difference, remember, it's you're subtracting the bottom minus the top. Yeah.
So wouldn't it be negative 5 then? Negative 8 is true.
So you're saying that it's, your first difference is going to be negative 5 for all of them? Is that what you're saying?
Yeah.
Yeah, it is. Yeah. But let's do it together. But yes, it is. It is going to be all negative 5. So if I do negative 3, be careful here because you have lots of negatives. Okay? Negative 3 take away 2. That's going to be negative 5. Then negative 8 take away negative 3. So be careful here. I have double negatives. So that's going to be negative 8 plus 3, which is negative 5. And negative 13, take away negative 8. Again, that's negative 3 plus 8, which is negative 5. And negative 18 minus negative, take away negative 13, that's negative 5. So you see that your first constant, your first difference, is constant. Okay? So again, this is another proof that this is a linear function. So you're going to have to write linear because first difference is constant. Now here's my question to you. If you're going to draw the x and y axis, how would you draw them here? What would you pick? You're going to draw the x and y axis. Would you draw it like this, or would you draw the x, like where would you give yourself more room?
For x is all positive and y is almost negative, so I will put it a bit
Higher. Okay?
Bottom.
Yeah, so instead of putting it low and then have all the positive y values, you would want to give yourself some room in the negatives, right, for the y. So I would put my x-axis somewhere right here because I need my negatives. So that's 1, 2, oops. 1, 2, 3, 4. I might not be able to fit all the points. What do you want to go up by? Where do you want to go up by? Do you want to go up by? Let's go up by or down by 5. Actually, it's going to be a little crowded. Let's go up by. Actually, no, that's fine. Okay, so first, my first point is going to be 0, 2, so it's going to be about here. My second point is going to be 1, negative 3. And then 2, negative 8. Again, this is going to be so like not detailed. 3 and negative 13. And then negative 5, yeah. Because if I do negative 18,
Yeah.
take away negative 13, that gives me negative 5.
Oh, I was thinking the other way.
So if you do negative 18 minus negative, yeah, 13, that gives you negative 5. Okay? Okay? So that's a straight line. Are we okay with this? Okay? So, equation, degree 1. Table, first difference is constant, graph, it's a linear function. Now let's look at this example. So the height of a ball by a child is modeled by the equation y equal negative 2x squared plus 8. Looking at this equation, what can you tell me? Quadratic. Quadratic. Why is it quadratic? Exponent 2, right? So if I'm looking at my equation, if you look at the degree or the exponent on the x, it's an exponent 2, okay? So once I see the exponent 2, I know it's quadratic. And that's the highest exponent that you have, okay? Degree 2. All right. Now they give me the x values 0, 1, 2, 3, 4, and I'm going to replace the x with the 0, 1, 2, 3, 4 to find the y values. So they did the first one for me, so I did replace x with a 0, so that's negative 2 times 0 squared plus 8. 0 squared is 0 times negative 2, that's still a 0. Add 8, that gives me 8. Okay? Remember, that math says you're going to have to do your exponent before you do your multiplication. Now, I'm going to replace x with a 1. I'm missing the square. So 1 squared is 1. Take away 2, multiplied by negative 2, that's negative 2. Add 8, that gives me 6. I'm going to replace the x with a 2. First 2 squared, that's 4, times negative 2. Then that's 8. Add 8, that's negative 8. Add 8, that's 0. So 2 squared is 4, times negative 2, that's negative 8. Add 8, that's 0. 3 squared is 9, times negative 2, that's negative 18. Add 8, that would be negative 10. Squared is 16 times negative 2, that's negative 32. Add 8, that is negative 20. All right, so I found my y values. Everything good? Negative 24. It's not very, I'll try to write it smaller. All right, first difference says what? What do I need to do for first difference? Subtract 8 from 6. So that means you're going to do 6, take away 8. So you always start with the lower y, subtract the one on top of it. Okay? So that's 6, take away 8. So that gives me negative 2. Now, you're going to do 0, take away 6. That gives me negative 6. Negative 10, take away 0. That gives me negative 10. gonna be negative 14. I'm just gonna write it in red because I think red can be seen better. So negative 24, take away negative 10, so that's plus 10. That's gonna be negative 14. Now, what have you noticed about the first difference? Is it constant? No. So if you look at your first difference, the answer here, it's negative 2, negative 6, negative 10, and negative 14. They're not constant. Okay? With the linear function, we found that the first difference is constant. But with the quadratic, first difference is not going to be constant. That's when we have to do the second difference. Okay? Now to do the second difference, I'm going to take the first difference and I'm going to subtract the second difference. So I'm going to do the same process, but using the first difference. Okay? So that means I'm going to take the negative 6 and I'm going to subtract negative 2. Okay? So negative 6 subtract negative 2. That's negative 6 plus 2, which gives me negative 4. Now, negative 10 subtract negative 6. That gives me negative 10 plus 6, which is negative 4. Then you're going to do negative 14, subtract negative 10, and that gives you negative 4 as well. Okay? So what do you see now? Second difference is constant, right? So, if you look at this, your second difference here is constant. And that proves it to be quadratic. Okay? All quadratic functions are going to have a second difference constant. Okay? So, if I don't know the equation and I do my first and second difference, my second difference, I know it's quadratic because my second difference is constant. So quadratic because second difference is constant. Are we okay with this? We're going to try to graph this, but I'll show you the actual graph once we try. We're going to try to graph it by hand, but I'll show you the actual graph on a graphing technology. Okay, so I'm going to go up by 2 like this. 2, 4, 6, 8. And then negative 2, negative 4, negative 6, negative 8, negative 10. Okay, so I'm going up by 2. On the y, on the x, I'm just going to do 5. So it's going to be 0, 0, 8, so that's my first point. Then 1, 6. Then 2, 0. And 3 is negative 10. And 4 is going to be somewhere right here. So it's going to be, if you look at this, it's not linear, but it's more like a slope. Yep. Not even like, it's more curvy. Okay? Now the thing is with this graph, we only have part of the graph. Okay? We don't have both sides of the graph. So yes, it doesn't look like the quadratic or the parabola, but remember that I'm only taking the positive values of the x, so there is another side of it on the other side. Okay? That's why sometimes you learn how to pick your numbers, right? The x values are important. Which x value can find it on your phones, or you can go online. It's called Desmos with a D, D-E-S-M-O-S. It's a good graphing calculator. Okay, so you can find the app online on a phone. I don't know why, what's going on with my internet. Looks like the internet's not working today. Okay, so what I want you to do right now is, if you have internet on your phone and you want to go to your search engine and search Desmos, D-E-S-M-O-S, graphing technology. And you can download the app if you want. I don't know what's going on with the internet. There you go. So it should look like this. It's the app will have like a graph. It's a green icon with a graph on it. So what was the equation? Y equal 2 or negative 2 x squared plus 8. Was it? Was that your equation, guys?
Yeah.
Okay. So if I enter it in Desmos, you see that it's a corrupt. Okay? So on your Desmos, if you actually download the app, if you need the square button, you see this right here, the A squared, you can press that for the square. So if you're entering on your phone, you can do this, y equal negative 2, and then you can press x, and then press that square button right here, not 22. And then plus 8. Okay? Are we okay with this? Okay. So what I want you to do right now is I want you to take some time to try to fill this table out. Okay? There's a lot of numbers here, so please be careful. Use pencil just in case. Okay? And fill this table out. What do we know about this equation? Quadratic.